Good day everyone. This is a tutorial on projectile motion problem solving part 1, horizontally launched projectile. Let's get into this.
Physics tutorial with Sir Kess.
Projectile motion is the motion of an object launched into the air with an initial velocity, moving under the influence of gravity alone, without any other external forces. The object follows a parabolic trajectory due to the combination of its horizontal motion with constant velocity and accelerated vertical motion. We can divide projectile motion into two types, horizontally launched projectile and projectile launched at an angle. Let us start first on the concepts of horizontally launched projectile. A horizontally launched projectile refers to the motion of an object, like a ball or bullet, that is projected horizontally from an elevated position. Ignoring air resistance, gravity acts downward as the only force, causing the object to follow a curved path towards the ground. The concept of projectile is a combination of horizontal and vertical motion. So we need to understand the properties of its horizontal and vertical motion. For its horizontal motion, its velocity is constant for the entire motion. Since velocity is constant, acceleration is zero. Its vertical motion follows a free-fall motion with acceleration equal to positive 9.81 meters per second squared, since the object's velocity is increasing as it falls. Also, the initial vertical velocity is always zero because the projectile is launched or released horizontally. This is an example why a horizontally launched projectile curves downward. A soccer player kicks a ball horizontally, giving it a horizontal velocity of 10 meters per second. So the ball will travel 10 meters horizontally every 1 second interval. For its vertical motion, we use the freefall equation for each second to calculate the height of fall. The ball will fall 4.9 meters for the first second, 19.6 meters for the next second, and 44.1 meters on the third second. The combination of horizontal constant velocity and accelerated motion in the vertical axis makes the curved trajectory of a projectile. We will apply this problem-solving strategy in solving horizontally launched projectile problems. Classify the given quantities as quantities for horizontal or vertical motion so that you will not be confused in what quantities to use and substitute in your solution. These numbers are just examples. The important thing to note is that you have to separate the quantities for the horizontal motion and quantities for the vertical motion. Like in here, the g and the zero initial vertical velocity is placed on the vertical motion since they are quantities for the vertical motion. For each question in the given problem, determine if it is referring to a horizontal or vertical motion. If the question is asking for quantities in the horizontal motion like the range or the horizontal distance or the horizontal velocity, then use the equations for constant velocity because the object is moving with constant velocity in the horizontal axis. If the question is asking for quantities in the vertical motion like height, vertical velocity, and time of fall, then use the equations for accelerated motion. Let us solve some examples. A ball is launched horizontally from a cliff 20.0 meters high with an initial speed of 15.0 meters per second. Calculate the following quantities. 1. The time it takes for the ball to hit the ground. 2. The horizontal distance it travels before landing. So we are given with the height of the cliff and the initial horizontal velocity. The other quantities that is not given by the problem is the acceleration of the object, which is 9.81 meters per second squared, and the zero initial vertical velocity. In solving projectile motion problems, it is very important to separate the horizontal and vertical quantities. The problem is asking for the time of fall and the range or the horizontal distance. The first question is asking for the time of fall, which suggests a vertical motion. So, we will refer to the vertical motion quantities, and we will choose from the UAM equations. From the given vertical motion quantities, the best equation to use to compute for the time of fall is the last equation, which includes height and the acceleration of the object. By substituting the given height and acceleration of the object to the equation, we get the time of fall, which is 2.02 seconds. Question number 2 is asking for the horizontal distance, so we will use the horizontal quantities. Take note here that we already included the time from our calculation in number 1. The time of fall is just the same time for the object to travel horizontally and land on the ground. Example number 2. A rock is kicked horizontally from the second floor of a building. It landed 12.0 meters from the building after 1.50 seconds. Calculate the following quantities. 1. Initial velocity. 2. Height of the second floor. The given quantities of tape problem are the time of fall, which is 1.50 seconds, and the range or the horizontal distance from the building, which is 10 meters. The initial vertical velocity is 0 and the vertical acceleration of the object is equal to positive g or positive 9.81 meter per second squared. The problem is asking for the initial velocity, meaning the initial horizontal velocity obtained by the ball from the horizontal kick, and the height of the second floor. Question 1 is asking for the initial horizontal velocity, so we will refer to the horizontal motion quantities and use one of the CVM equations. For the second question, it is asking for the height of the second floor. The height is a vertical quantity, so we will refer to the given vertical motion quantities and choose from the UAM equations. Equation 3a can be used to solve for the height of the building since it contains the variable initial vertical velocity, time, and acceleration. This is the last example. Pause the video and try to solve for the answers using what you have learned in solving projectile motion. Thanks so much for tuning into this tutorial. Hope you had a blast learning with me. If any questions pop up, just drop a comment below. I'd love to chat about it. See ya on the next tutorial. Take care always.